Welcome, and thank you for joining this webinar, From Connectivity to Sensing Revolution, How Wireless Can See the Invisible, prepared by Alpert Research Team. Today, we're exploring how wireless sensing isn't just another buzzword, it's the fusion of communication networks with environmental awareness, turning everyday Wi-Fi routers and 5G towers into silent sentinels that detect motion, monitor health, and optimize cities without adding hardware.
Why this paradigm shift now? What's the data telling us?
The timing, well, it's pretty much perfect. It's because of technological convergence. You've got the maturity of 5G infrastructure, the push towards 6G, the sheer number of IoT devices out there, and maybe most importantly, the sophistication of artificial intelligence. We finally have the computational power readily available to refine that raw, often noisy signal data into actionable insights. That just wasn't really feasible on a large scale 5 or maybe even 3 years ago. Based on the Alpert Research Team's analysis, the global wireless sensing market is projected to grow. We are looking at a surge from about $14.9 billion in 2024 to over $150.4 billion by 2032.
Wow, that's nearly a tenfold increase in less than a decade. That points to a compound annual growth rate, CAGR, exceeding 20%. That kind of growth doesn't happen without some serious underlying demand. What are the key market drivers fueling this?
The demand is being fueled primarily by 4 massive verticals. Healthcare is a huge one, automotive, smart cities, and heavy industry like manufacturing and logistics. And if you look across the broader ecosystem, the traditional wireless sensor network market, the WSN segment, which is now starting to incorporate this device-free sensing idea, that's also expected to reach something like $79.6 billion by 2035. The whole sensor landscape is reshaping itself around this perception capability. That economic argument also seems really strong, the economic efficiency aspect. You mentioned leveraging existing infrastructure.
The fact that you can potentially use your existing Wi-Fi access points, your network interface controllers or NICs, or your 5G base stations, it dramatically changes the return on investment, the ROI calculation. You're leveraging the sunk cost of all that connectivity infrastructure you already paid for.
And this efficiency then meets a real need, the IoT ecosystem demand.
Pretty much every major industry, vertical smart homes needing non-intrusive monitoring, healthcare, precision industrial automation, smart cities, they all need better ways to do contactless, pervasive sensing. WST fills that gap. If companies have to invest heavily in specialized edge AI processing, training these complex models, what does the true ROI timeline look like? Is it really that immediate?
The immediate 60% cost saving you see is primarily in the deployment phase. However, you are absolutely right. The expense shifts. It moves away from CapEx, the hardware purchase, towards OpEx software development, needing AI talent, data labeling, model maintenance. But the ROI timeline is accelerated quite significantly because we're leveraging COTS. Commercial, off-the-shelf hardware.
Okay, so using stuff that's already mass-produced.
Dramatically lowers the barrier. It accelerates the machine learning development cycle because you suddenly have access to vast amounts of data from existing, widely deployed protocols.
So the economic angle is that COTS drastically reduces the hardware barrier to entry. It shifts the competitive landscape more towards who has the superior software, the most robust AI model.
And there's another benefit too, the network itself becomes more efficient. By using this sensing data to proactively optimize communication, sometimes called sensing-assisted communication network, can actually realize significant energy savings. We're seeing figures around 30%. If the network knows where a user is moving or where obstacles are, it can adjust things like beamforming much more precisely, almost instantly. It avoids wasting power transmitting signals where they aren't needed.
Can you give us a couple of concrete examples of the urgent needs driving this adoption?
Sure. Look at the demographics in many developed countries, the global aging population. There's a massive growing demand for continuous but non-wearable health monitoring. Wireless sensing allows for contactless detection of vital signs like breathing rate, heart rate, and critically fall detection for elderly individuals living alone. It addresses a huge need for safety without forcing someone to wear a potentially uncomfortable or stigmatizing device 24/7.
And the other example?
Modern manufacturing and logistics. They require predictive maintenance sensing minute vibrations in machinery before it fails. They need worker safety monitoring, especially in harsh or isolated environments. Sensing technology, particularly RF sensing, can meet these demands. Because it's robust, it often works through occlusions like walls or equipment, which cameras can't do. So the market isn't just being pushed by cool new tech, it's being actively pulled by these massive unmet societal and industrial needs. You mentioned technological convergence.
Yes, there's a perfect storm of three key forces aligning. First, you've got the sheer ubiquity of wireless infrastructure. Wi-Fi 6, 6E, 5G are everywhere, and 6G is on the horizon. The density is incredible.
Sort of foundation is there.
Second, massive leaps in signal processing power. We can now actually make sense of these incredibly complex wave perturbations in real time.
And the third piece.
Artificial intelligence. AI has matured to the point where it's essential for translating that raw wave data, just numbers, really into actionable insights. AI connects the dots. Two things really accelerated practical adoption. First, the definite move towards 6G standards that explicitly natively integrate sensing. This concept is called ISAC, Integrated Sensing and Communications. But the key point is that sensing becomes a first-class citizen in the network design, not an afterthought. Second, was the growing availability of commercial, off-the-shelf hardware, COTS hardware, that can easily extract the raw data needed. Specifically something called Channel State Information, or CSI. That opened the floodgates for building practical sensing platforms outside of major corporate labs.
Right, it moved from purely theoretical to something people could actually build and test. The big strategic takeaway seems clear. We're really moving beyond just connectivity. We're turning signal interference, which used to be a nuisance, into valuable insight.
So what does this all mean? The message is clear. This wireless technology isn't just enhancing networks. It's enabling a sensing revolution that redefines interaction with the physical world. Interested in gaining a deeper understanding of the transformative power of wireless technology? Join the Alpert Research Team's webinars to explore cutting-edge wireless innovations, their applications, and their implications. Click the links below to learn more.